Exercise 14.5 is a set of 3 questions on laws of logarithms for GCE A-level Pure Maths Year 1. So question 1, A. Given that log to base 3 of x plus 1 minus 2 times log to base 3 of x minus 1 is equal to 1, show that 3x squared minus 7x plus 2 is equal to 0. Hence, or otherwise, solve the equation log to base 3 of x plus 1 minus 2 times log to base 3 of x minus 1 is equal to 1, given that x is greater than 1. So for A, I'm going to rewrite the whole equation, but this time I'm going to change this term using the power rule over here as follows. Log to base 3 of x plus 1 minus log to base 3 of x minus 1 all squared is equals to 1. That's the first step. And then I'm going to use rule number 2 to rewrite the left-hand side of the equation as follows. Log to base 3 of x plus 1 over x minus 1 all squared is equals to 1. Then I'm going to use the definition rule here to rewrite the whole equation. If I do that, I'm going to get x plus 1 over x minus 1 all squared is equals to the base, which is 3 raised to the power 1. 3 raised to the power 1 is equals to 3. And so the whole equation now becomes x plus 1 is equals to 3 brackets x minus 1 all squared. If I expand the x minus 1 squared, I'm going to get x plus 1 is equals to 3 brackets x squared minus 2x plus 1. And then I'm going to expand the right-hand side of the equation, and I get x plus 1 is equals to 3x squared minus 6x plus 3. And I'm going to transfer the x and the plus 1 to the other side of the equation. And if I do that, I'm going to get 3x squared minus 6x minus x plus 3 minus 1 is equals to 0. And simplifying, we give 3x squared minus 7x plus 2 equals to 0. And this is what we are required to show. For B, since we know that this whole equation has been shown to be equal to this, all we do now is solve this equation. So 3x squared minus 7x plus 2 equals to 0. If I multiply 3 by 2, I'm going to get 3 times 2 equals to 6. And if I base 6 down, I'm going to get 2 factors, which will be 6 and 1. And so minus 6 times minus 1 will give me 6, and minus 6 minus 1 will give me minus 7x. So we can proceed and do this. 3x squared minus 6x minus x plus 2 equals to 0. 3x can come up, and I'll get x minus 2. Similarly, minus 1 will come out on that side, and I'm going to get x minus 2 equals to 0. And so finally, I get x minus 2, 3x minus 1 equals to 0. And that means either x is equal to 2 or x is equal to plus 1 over 3. But x must be greater than 1, and so x cannot be equals to 1/3. And so the answer required to be x is equals to 2. Question 2. Without using a calculator, solve the equation log to base 5 of x equal to 16 times log to base x of 5. B. Without using a calculator, evaluate log 6 plus log 4 plus log 20 minus log 3 minus log 16. So for A, I'm going to change log to base x of 5 to base 5 using the change of base rule. So if I do that, I'm going to get log to base 5 of x on the left-hand side, and the right-hand side becomes 16 times log to base 5 of 5 divided by log to base 5 of x. So that's how you can use the change of base rule to change log to base x of 5 to base 5. And we can also see now that log to base 5 of 5 is equals to 1 according to rule number 1. And so the whole equation becomes log to base 5 of x is equals to 16 divided by log to base 5 of x. I can now take this one to that side to get log to base 5 of x all squared is equals to 16. And now if I find the square root of both sides, I'm going to get log to base 5 of x is equals to plus or minus 4. So it means either log to base 5 of x is equals to 4, which implies that x is equals to 5 to the power 4, according to the definition of logs. And this is 625. So that's the first answer. Or we can have log to base 5 of x is equals to minus 4, which implies that x is equals to 5 to the minus 4, again using the definition rule here. And this will be equals to 1 over 5 to the power 4. And so x can also be equals to 1 over 625. So these are the two answers for question 2a. For question 2b, please note that when we write log a, for example, without any base, this means log to base 10 of a. That's the convention. So log written without any base means log to base 10. And so for question 2b, all these bases here are base 10. So I'm going to rewrite the whole equation again, but I'm going to introduce brackets conveniently to enable me to solve this question as follows. So I can have log 6 plus log 4 plus log 20 minus. Then I introduce brackets as follows. Log 3 plus log 16. I can now apply the multiplication rule, rule number 2, to this and to the expression in brackets. And now if I do that, I'm going to get log 6 times 4 times 20 minus log brackets 3 times 16. Now I can apply the division rule to this as follows. Log 6 times 4 times 20 divided by 3 times 16. Now doing some cancellation, I have 3 goes here 1, 3 goes here 2. 4 goes here 1, 4 goes there 4, and 4 goes here 1, and 4 goes there 5. So finally, I'm left with log 10. But as indicated earlier, this is the same as log to base 10 of 10. And using the first rule here, we can conclude that the answer is 1. And so the solution for B is 1. Question 3. Without using a calculator, solve the equation log to base x of 9 plus log to the base x squared of 3 is equal to 2.5. B. Given that log to base 9 of x is equal to m, and log to base root 3 of y is equals to n, express the following as powers of 3. I, x times y, and I, x squared over y. So for A, I'm going to use the change of base formula to change this base to x, so that to have the same base as this one here. But I can also rewrite this one differently as follows. Log to base x of 3 squared instead of 9. So 3 squared plus, if I change the base, I'm going to get log to base x of 3 over log to base x of x squared. And that will be equals to 5 over 2, which is the same as 2.5. I can use the power rule to change both this term and the denominator here as follows. Log to base x of 3 times 2 plus log to base x of 3 divided by 2 log to base x of x, and that is 5 over 2. So please note I've used the power rule to change this term here and the denominator to this. We can now see that log to base x of x is 1, and so we can rewrite the whole equation as follows. 2 log to base x of 3 plus log to base x of 3 over 2 is equals to 5 over 2. Then I can multiply each term by 2 to simplify the equation. If I do that, I'm going to get 4 log to base x of 3 plus log to base x of 3 is equals to 5. But 4 lots of log to base x of 3 plus one of them here will give me 5 log to base x of 3 equals to 5. If I divide both sides by 5, I'm going to be left with log to base x of 3 equals to 1. And using the definition rule here, I'm going to get 3 is equals to x to the power 1, which implies that x is equal to 3. And that is the answer for question 3a. For B, log to base 9 of x equals to m implies that x is equals to 9 to the power m. But 9 is the same as 3 squared, so we can write this as 3 squared, all of that raised to the power m, which means this is 3 to the power 2m. Similarly, log to the base of root 3 of y equals to n implies that y is equals to square root of 3 raised to the power n. But square root of 3 is 3 raised to the power half, so it means this is the same as 3 raised to the power n over 2. So now we have the values of x and y. So if we multiply them for I, xy will become 3 to the power 2m, which is here, times 3 to the power n over 2. We have the same basis, and according to the laws of indices, when we multiply two numbers with the same basis, we can add the powers. So we are going to get 3 raised to the power 2m plus n over 2. And that is xy written as a power of 3. For I, we require to write x squared over y as a power of 3. And this is therefore equals to x squared. We know that x is 3 to the power 2m. So that will be 3 to the power 2m all of that squared divided by y, which is 3 to the power n divided by 2. This is equals to 3 raised to the power 4m divided by 3 raised to the power n divided by 2. According to the laws of indices, this will be the same as 3 raised to the power 4m minus n over 2. And so this is x squared over y written as a power of 3. And this concludes this session on laws of logarithms. Thank you for watching, and I'll see you in the next video.